Sir, you can start the session, sir. Prabhu, Bharati madam. Bharati madam.
Sir, Senthil sir, you can you start, sir?
Prabhu sir,
Yes.
it seems only 10 members have joined in this.
Yes, sir. We are waiting for them, sir. So we have informed to the participants, sir. Let them
Okay.
join me, then we can start, sir.
Okay, sir. Okay, sir.
Hello, sir.
Hello.
Am I audible, sir?
Yes, audible, madam.
So, shall we start, sir?
Yes, 12 members. Sir, Prabhu, sir. Prabhu, sir. 1 minute, madam.
Yes, sir. Yes, sir.
Sir, what happened to YouTube? They have joined, huh?
Yeah, they are joining, sir.
Okay, right. Then we'll start the session, sir. So, Ravi, sir, will start, sir. So, all the participants will be joined in the YouTube, sir. YouTube channel is given for them. Hello.
Yes, sir. We need to introduce our first person.
Okay, right.
Yes, sir.
Shall we start, sir?
Yes.
Sir, I will start. So, very good evening to one and all present here. It is with great pleasure and pride that I extend a warm and heartfelt welcome to each one of you to this prestigious faculty development program organized by the Department of RM Communication Systems, SIMATS Engineering. The theme of our 6-day FTP is Intelligent VLSI, the convergence of AI, signal processing and computing. Today, we are especially honored to have Dr. Ravi, Associate Professor, EC Department, Hudlaveru Engineering College, Andhra Pradesh, as a resource person for our Day 6. His session on Fundamental and System Verilog Programming. It will undoubtedly be a valuable learning experience for all of us. Welcome you, sir. Now, Dr. Prabhu, sir, will introduce the resource person. Dr. Prabhu, sir.
Yes, ma'am. Thank you, ma'am. It's my pleasure to welcome Dr. S. Ravi, sir. Welcome you, sir. Dr. S. Ravi, sir, is working as an associate professor in Sri Sheshadri Rao Skudla Valleru Engineering College, an autonomous institution in Andhra Pradesh. Sir has completed his postgraduate cum doctorate in VLSI design from Anna University. He has a very good exposure to ASIC and FPGA technologies, having a good programming skills in HDL language. He has worked as a associate professor and assistant professor for the period of more than 16 years in various engineering colleges in Tamil Nadu and Andhra Pradesh. He has published more than 37 papers, including Scopus and international conferences. In addition, he has published 2 book publications and 4 book chapters and 4 patents. And he has organized more workshops and seminars to his credit. So I welcome you, sir. This is the platform for you for today's session. Thank you.
Thank you very much, Prabhu sir. Thanks for the nice introduction. So I would like to share my screen to start the presentation.
Yes, sir. I will stop my sharing.
Thank you very much, sir. Is my screen visible to all of you?
Yes, sir.
Yes, sir. Yes.
Excuse me, sir. 1 minute. Let me turn the camera on. So that's another criteria to be followed that I forgot. Is it okay now, sir?
Yes,
yes,
sir.
sir.
Yes, sir. Can you put a full screen, sir? PPT.
Yes, sir. I make it, sir. Now it's. Good evening to everyone, dear participants who are the faculty members of various colleges. It is my pleasure and privilege to interact with you on this wonderful topic called Fundamentals of System Verilog Programming. This particular programming language, am I audible to everyone, sir? Am I audible?
Yes, sir. Yes,
Yes, sir.
audible, sir.
Okay, sir. Okay, sir. Sometimes in the group also, if any problem, please share that, sir. In the group itself, no problem, sir. Any voice or screen issue, please share it in the group, sir. I'm continuously watching this particular WhatsApp group. Okay, so this particular System Verilog programming is one of the emerging languages. I can say that we can encourage our students, both undergraduate and postgraduate students, to do their projects. And next thing is, whoever is interested in doing projects with respect to software development, they can also go for doing some research with respect to System Verilog programming. So, not to take much of your time, let me move on to the contents of today's presentation. So first we are going to see simple introduction to Verilog HDL, what exactly hardware description language is, what is the need for it. Then how Verilog HDL becomes System Verilog, what made the language to be introduced. We will see that one also, followed by a hands-on session. We are not going to see any of the example programs before hands-on. The programming, before I explain the program, we are going to practice with the EDA Playground, one of the open source online platform which can be accessed by anyone at free of cost at any time. You can access it, provided you should have internet connection. That's all. So such a wonderful platform, we are going to make use of it to practice this System Verilog programming. Once we complete the demonstration and practice, we are going to see some sample programs, both combinational and sequential circuits description using System Verilog. And this is going to be clear or a very basic level of explanation for system Verilog programming. Once we have done these fundamentals, like again we are going for hands-on session through which we are going to verify the functionality of full adder. And this verification is going to be a broad range of verification or a complete verification. If time permits, we'll discuss about data types in system Verilog, what are the new things introduced in system Verilog, followed by research directions for some of the faculty who are interested to do some research, means they can take up research aspects also in system Verilog programming. So what are the prerequisites to understand this system Verilog programming? The very first thing is digital logic design, because the language itself intended for designing and verifying digital logic circuits, right? It could be a simple AND gate or OR gate or XOR gate, right? Starting from an adder or subtractor. We may go up to designing system on chip, an embedded system, or it could be a digital signal processor. We may be designing. That we want to verify means we can make use of system Verilog program. And followed by familiarity with the C and C++ programming will be an added advantage for you. Somebody who has familiarity with the C programming as well as C++ programming, this system Verilog is going to be much easy for you, because the syntax of this C programming, Verilog program is similar to C, and system Verilog program is going to be similar to C++, right? So from this perspective, either C or C++ will help you to understand this programming language much easier. Like in our UG laboratory, with the help of this simulation tool, means it will be easy for you to learn the EDA playground also, which we are going to practice today. So as a whole, or as a broad picture, I would like to start from how a digital system is being developed from the scratch. If you consider the bottommost aspect is the transistor, right? Considering a MOSFET, you can see it has three terminals like source, drain, and gate, which everybody knows. And everybody, most of the electronics engineer think that transistors are diodes, which comes only at the electronic devices subject. Later on, it doesn't play any role. Only the VLSI design engineers know the importance of this particular concept, because the transistors are interconnected together. We build any of the logic gates. As you can see, an inverter in this diagram, right? A PMOS and NMOS transistor combined together, which builds a simple NOT gate. As per this diagram, you can build any logic gate by combining PMOS and NMOS transistors, which is called the popular technology, CMOS technology. And once we develop these things, we create an abstraction, right? Instead of showing in terms of transistor, we show in terms of logic gates with its own symbol, like AND, OR, and all, right? And followed by this, combining the logic gates, we build adder, subtractor, multiplier, and all. These are called RTL, register transfer logic level modules, multiplexer, encoder, decoder, etc. Once we have these modules, we move on to a processor. A processor having arithmetic and logical unit, timing and control unit, set of registers, right? Anything, if you see, it is a collection of register transfer RTL modules. So as a whole, what I would like to say means we should have a flow in our mind that combining the logic gates, we build little complex blocks or RTL blocks like adder, subtractor, multiplier, or shift register, counter, etc. Those RTL level blocks will be combined together to build a processor or a microcontroller or a signal processor, right? And system on chips and so on. And what is the role of hardware description language here? If you can take an example, in the year 2022, Intel has introduced 13th and 14th generation Raptor LAC processors. Without understanding the internal bugs they have sent to the market, after 2 years of its usage, a professor from an university identified for some of the input conditions, the system starts to fail. And also for a different environmental condition also, the chip has started failing. So due to lack of proper verification, this chip has failed, and Intel has introduced a piece of subprogram. That program helped to save some of the chips, but the previously failed chips and all they could not replace it. So that found some loss for the company. The same thing happened in 1994 also when Intel Pentium was introduced with the floating point division unit. Right? Everybody know division, right? The same thing with the floating point numbers, high precision numbers. And that also found some bugs due to lack of improper verification, right? So verification play a key role whenever you want to succeed in processor manufacturing or processor design and bringing it to the market for various applications. So what is verification basically? It is a process of ensuring that a given hardware design works as expected. So when it is an adder, it should add. When it is a subtractor, it should subtract, right? And there could be some extraordinary scenarios where it fails. At corner cases, we should identify and test the module or verify the module in all circumstances and ensure that it works properly, right? While chip design is somewhat easy, verification is a time-consuming process. That is one of the need for introduction of hardware description languages. So before manufacturing a chip, we model the entire modules within the system. We apply set of inputs to the model and verify the results. Once we find that it is okay, we go for fabrication. So there is a key difference between verification and testing. Before fabrication, if you test a module, it is called verification. Once we fabricate and we apply the test pattern and verify a system, means it is called testing. So verification prior to fabrication, testing after fabrication, right? So that is a marginal difference between verification and testing. Now coming to hardware description languages, because we want to create some model, right? In order to apply some input and verify its functionality, we need to create some model. How do we describe the model to a computer system or a software tool? Using hardware description languages like Verilog HDL and VHDL. What is the need for those hardware description languages? Already we have C and other programming languages like Fortran. What could be the need of hardware description languages? Generally, the sequential programming languages represents the sequential nature of a computer system, which executes only one instruction at a time. In a clock cycle, it fetches an instruction, then decode, execute, and go for the next instruction, right? Whereas in hardware, if you see set of logic gates, when you apply the input, all logic gates take the input, process its own values and pass it to the next stage. Then the next set of gates in parallel works together and pass it to the next and so on, right? So this is the concurrent nature of the hardware. This cannot be modeled with the sequential nature of programming languages. For that reason, we go for hardware description languages. One of the popular hardware description languages, Verilog HDL. So which precisely models the concurrent or parallel nature of the hardware, right? That is one of the things. And also these hardware description languages help us to verify for various input conditions and ensure that this system can be fabricated very well. And after this assurance, we go for fabrication. And here comes a simple introduction to Verilog HDL. As we are going to see some of the example programs with Verilog HDL, we will come across these facts. First thing is Verilog HDL is easy to learn as well as use because it follows a syntax of C programming languages, which is common for most of the engineering branches. So someone says that who is familiar with the C programming means definitely he or she can understand Verilog HDL also. And it supports different levels of modeling, right? Different levels of modeling means we describe the functionality of hardware at the gate level, or we may be representing as a block and taking its input called the data flow, or we may be representing like a C programming with the for loop, if loop, while loop, and do while loop, and so on, right? So that also can be used to model any of the hardwares. Verilog HDL program supports all these different styles of modeling under single module itself. So within one single program, we can go for mixing all these different models itself. There is no harm or wrong with this particular procedure. So one particular language for design block and for test bench. Can somebody please, okay, it is a bit difficult, I believe. The test bench. I hope everybody know what is test bench, right? Test bench means So somebody please answer in the chat box for our FDP. What is test bench in your opinion? Because the whole session mostly concentrate on test bench only. If somebody can answer in the group, it is well and good. Any opinion? What is test benches? I don't follow YouTube, sorry. If I follow that, I may follow your comments or chat window. Actually, I am in WhatsApp only. Okay, let me come to this point. A test bench means a program which is used to generate the set of input patterns for that design unit what you have created. Maybe an adder or subtractor. If it is an adder, we have to generate some two inputs, right? A and B. If you apply, the adder is going to add and gives you the result. And we can observe the response of this adder and we will be able to verify with the help of waveform. Does it work properly or not? So for that, we describe everything in the form of a program called test bench. Followed by this supports hierarchical design. Hierarchical means like if you design half adder, you can combine half adders to go for full adder. Once you design full adder, you can go for parallel adder by combining multiple full adders. The same way you can build ALU. ALU may be called into a processor. Processor may be called into a controller, right? In that way, you can go for hierarchical way of designing your system to any complexity, right? And the another advantage of Verilog HDL is that most of the synthesis tools which are available in the market support Verilog HDL. So whatever the design you have developed or modeled using hardware description language, that can be directly synthesized into hardware, maybe an FPGA, or it may be converted into GDS2 file through various process steps like backend process that you could have understood in the very first day of your session, right? Front-end design and physical design. That physical design, through that also you can apply Verilog HDL as an input which can be translated into various process. Finally, you can create a GDS2 file which will help you to create a particular IC for a dedicated functionality, right? In this way, Verilog HDL has many advantages. And what about System Verilog? System Verilog is an extension of Verilog, right? How we have extended C++ from C by introducing object-oriented programming concept. In the same way, Verilog has been extended to System Verilog by introducing object-oriented programming concepts like classes, objects, inheritance, polymorphism. In addition to that, like different new data types, arrays, strings, different concepts are introduced in order to design as well as verify your system in a much simplest way or a comfortable way. They have developed a System Verilog. So initially the System Verilog had a unique module for design, then for verification. Assertion is also one kind of verification approach which helps you to ensure a system functionality. And finally, functional coverage. That means how much amount of specifications have been met by the design. That you can estimate like 100% or 80% we have verified. Like that we can evaluate the functional coverage of your verification. For that also we had System Verilog set of operators and system language constructs. Combining all these things together, we have got System Verilog language which has a latest standard of IEEE 1800-2023. Okay, so to discuss more on this Verilog versus System Verilog, as you can see, Verilog uses some of the concepts from C and Fortran programming, whereas System Verilog uses Verilog programming. In addition to that, we have VHDL, some concepts from VHDL, and also some of the concepts from C++, especially the object-oriented programming. Right? So that is the extension of Verilog becomes your System Verilog. And also, System Verilog helps you to go for class level test bench. For this, we are going to see one example. Class level test bench means you create a class. You can call set of objects for the class what you have defined. And every time you call an object, you can pass on different arguments. You can test it in a different scenarios, right? And also it helps you to go for some modular approaches. From one class, you can derive another class. So such kind of modular and reusable concepts are being introduced into System Verilog because we are introducing object-oriented programming concepts. And finally, because we are introducing object-oriented programming, it helps you to create some reusable components. Generators, drivers, monitors, all these things we will discuss in the upcoming session. I mean to say upcoming slides. And there are other aspects like hardware description language is used for modeling. Verilog means your system Verilog having the features of modeling as well as hardware verification. And new data types have been introduced into system Verilog. Okay. Any questions up to this? Any questions? Any questions? Someone says couldn't join. Let us see to that. Let us see to that issue. Prabhu sir?
Yes, sir.
Are the things going well, sir? Is everything okay?
Okay, sir. Okay, sir. You can proceed.
Okay. Someone says that unable to join. Can you please add them into that?
Actually, we have allowed all the participants to join in the YouTube only.
Okay.
Uh,
Okay. So now couldn't join again. Someone says the same thing. Okay. Other than that, if you have any questions, please post it in the group. Anything you want to convey? Okay, let us move on to the hands-on session. I want everybody to go for edaplayground.com. edaplayground.com. I will share you a link. Everybody please copy and paste that link. I post it in the WhatsApp group. Everybody, I have shared 3 links for you. First one, Andigate. Dear participants, I have shared the link in the group itself. The same I share in the form of a document also into our WhatsApp group. So everybody please you can open this file a simple text file I have shared in the group. Can I have some response from our participants in the group? I could see almost 23 members who are online in the WhatsApp group. Is everyone able to follow? Have you all got the link? If at least some 5 members convey yes means thank you very much, sir. Someone has responded in the group. Thank you very much. So I look for response from at least some 5 to 10 members so that once you are ready, I suggest you to open the first link. Click on the first link for Endgate. Everybody can click on the link and open and see. EDA Playground for Endgate, the first link. And for your convenience, in the screen, in my screen also, it is visible for you. Is it visible for everyone? In my screen? Almost good, sir. Sir, YouTube video is not clear. I do not know the problem, sir. Is my screen at least visible, sir? Is my screen at least visible? Sir, if possible, you may join with Google Meet also. And I suggest you to open the link. Whatever link I have given, you open in your mobile itself. Definitely, you can view the program on your own. Yeah, thank you very much. Someone also responded, visible, good. Maybe due to internet connectivity issues, some lack of clarity could be there. Kindly ignore it. And if possible, you open the link in your mobile itself. You please listen to the audio. Definitely, you can get it. Okay? Has everybody opened it? I look for responses from you because it is an hands-on session. Just another 2 minutes. Let me get response from 2 more members so that I will proceed further. Okay? Okay, thank you very much. So I'll proceed with this because not to waste much of your time. Module, any program, Verilog program, if you consider our system Verilog program, generally starts with the keyword module, as you can see here. And this particular double slash, right? The double slash, what you see here, it is for single line comment. In Verilog programming or system Verilog programming, the double slash represents comment. We normally say it is front slash, right? Module, it is the keyword which indicates start of the program. End module, which represents end of the program. Followed by module, we have module name. And you can give any name of your convenience, but please see to that it should not be a keyword. As we all know, and is a keyword in Verilog programming, so better avoid this. So instead of using and, use some additional words, right? I have mentioned underscore check. And I mentioned the list of ports involved in this design. So I say there is a port called Y and there is a port called A and B. So at this point, I have mentioned only list of ports. This is called port declaration, right? I have declared the ports. Now I am going to define the ports. What are the ports are inputs and what are the ports are output, which I carry out separately in this. So I claim that I want to use Y as my output port, A and B as my input port. Right? For any combinational circuit you can try. I have mentioned here for AND and you can try for OR gate. Look at the keyword here, assign. Assign is one of the keywords for data flow modeling in Verilog HDL, the same as I said in system Verilog also, right? It is an extension. So it is for continuous assignment. when there is a change happens in the right side variables, it will be immediately reflected into left hand side variable. The variables what I consider as input ports A and B are my inputs. Performing AND operation between the two, the result is assigned to Y. Right? Any questions or doubts with respect to the question, program here? This is called our design unit. Any questions? If so, please post it in the group. There are two parts here. As per this diagram, the right hand side, what you observe here is called your design module. And the left hand side, what we have is called your test bench program. We're supposed to start with our design first. Okay, so we go for design first, and we start with the keyword module and end with end module. And here we have specified module name, all those things. If you have any questions, you can post it in the group. Else, I'll move on to the next one. Someone says no. The same thing from one more participant. Thank you very much for your responses. Actually, your responses encourage me go forward, as well as gives me interest to speak more or convey more, right? Instead of being monotonic. Thank you. And now let us move on to the left hand side part, right? How to write a test bench. So before you write a test bench, please bring the concept what we have discussed in the introduction section, right? Test bench for generating the input, applying the input to the design what we have carried out before. And once we apply the input, the design is going to generate the response, right? The response we have to display in the form of wave or text, so that we can verify that the design, what we have done in the name of design, is working properly or functionally correct. So that we are going to ensure with the help of this test bench program. The test bench program also starts with the keyword module and terminates with the keyword end module. Okay, if you want to, you pull it down so that the thing is visible completely for you, right? Is everything okay? So I have started with the keyword module, terminated with the key end module, and the point where we are going to focus here is this particular portion. Everybody pay attention to this particular portion, because explaining the things in a line by line way may take more time, right? Because we need to have some changes in the program, we need to verify with a different set of input conditions, right? Then only it will be called a hands-on session. And I look the same thing from you also. Please look at this particular portion. And here I start with the keyword called initial and terminate the particular initial. That means my block, initial block, with the keyword I create the initial block. If I have here A as 1 bit 0, E as 1 bit 0. After 10 units of time, like according to the simulator, it may vary. So in this simulator, I say that after 10 units of time, maybe nanoseconds or picoseconds, the scale you can change, right? So as per your convenient timing, after 10 units, I change that A remains 0, but B changed to 1. Again, after 10 units of time, I change A into 1, then B becomes 0. After 10 units of time, A becomes 1, B also 1. Right? These are the set of inputs I would like to apply. And where I have to apply the input to the design unit, right? So into this particular test bench program, I call my design unit called and check. Please look at the module name here. In our regular practice also, we assign name to individual human being, right? We call them by name. In the same way, this is our design unit having the name called and check. The same thing I have to call into my test bench program with the same name. And if at all required, you can assign some instance name. Otherwise, by default, the system will assign. This instance name is not mandatory, but assigning instance name is a good practice, right? And that will help you to give some hint on that. When I use it in this situation, how do I use it? When I use it in some other situation, how do I use it? So in that way, you can assign some instance names that will make you to verify in a complex system. So I have assigned an instance name called A1. You assign C1 or D1, whichever name you want, right? There is nothing wrong with that. You can change the name also. Once you have done this, go for the save. Whenever you make some changes, go for the save. All right. So this is my test bench program. Inside the test bench program, I call my design program and I am applying different set of input combinations. Okay, I have applied. How do I observe the response? I should monitor it, right? How the things are changing. For that, I am using a keyword called $monitor. So the $monitor takes some set of arguments. The argument is first one is time. As a first parameter, I specify time means initially I have mentioned the time as 0. Later on, after 10 units means time will be updated to 10. So every time there is a change in values within these parameters, naturally this monitor statement will execute or call again and again in order to show the results, right? So time equal to 0, later it becomes 10, again 10 means yearly 10, now becomes 10 means it becomes 20 units of time. So like that it gets updated like 30, 40 and all. And I am passing the variable A also, because if any changes happen in A in I want to look at it. And what about this percentage B? Can somebody please tell me what is this percentage B? Sir, someone asked a very good question, sir. Sir, initially I go with a demo, sir. I just describe the program for you. Then immediately you can go for practice, sir. I will give enough time for practice also, sir. So at this moment, I just describe only the program for you so that it will be easy for you to change and verify the results. Nothing beyond, sir. Thank you very much for posting this message. And now coming here, monitor, $monitor is a system task. So it is going to monitor the parameters what I have mentioned inside the bracket. Sir, I want to monitor only A and B. It is good. I just want to monitor the time also. It is okay. You add it. By keeping comma, you can add any number of parameters of your design. Right? So A in, B in, I want to follow my right output also. So it may be missing somewhere here, I believe. So A in, B in, followed by out, because the third variable is my out. So those variables are specified within the bracket means that will be appearing, right? With the name A in equals, with the name B in equals. What about this percentage B? Percentage B is called format specifier. You want to display the results in binary, you specify here B. You want to display it in decimal, keep it D. In case of hexadecimal, keep it H. In case of octal, you specify O. It is the way we want to display it on the results. In case of waveform, we have the provision to change the value of each variable there, right? By changing the radix or number system. Okay. I hope everyone is clear at this moment, right? So I want to monitor the variable A in terms of binary. Same way B also, same way the output variable. Once I specify within the bracket, then I need to specify. What about the first argument? Percentage B, you pass it here A in. So B in you are displaying means pass on B in the same way out also, right? And the last block or third block is very interesting block. You want to observe the result in the output waveform means whatever the inputs we have applied and how we have monitored the response, all these things should be written into a file called dump.vcd. It's a default file, value change dump file. Into this, all the changes, the input, time, output values, everything will be written into, right? The destination file name is dump.vcd. This will be captured or taken by the EP wave, right? Here you can see open EP wave. EP is nothing but EDA playground. So waveform analyzer. So EDA playground waveform analyzer, in short, it is called EP wave. We want to see the results in EP wave means this we can do. Only we want to display the result in text form means $monitor is sufficient. I hope at this moment it is more than sufficient. If you still have any questions, you can ask. I give you 2 minutes of time. If you have any questions in this particular design and test bench program, you can ask now. You can put it in the chat box. If somebody find it difficult to type it, please post it as a voice message also. Nothing wrong with that. Sir, I find it difficult to communicate in English. Let it be in your mother tongue. Let me try to understand or observe it. After all, we are here to learn something about System Verilog, right? Please post your questions here. Anything about design or test bench program? Okay, whenever you make some changes, as I said before, save your program. I couldn't see anybody is typing. That is the reason I go with the procedure. If you have any questions, no problem. At any point in time, you post it in the WhatsApp group. I am here to answer for you. Now what we do, we go for running the program. Click on run. Please click on run. Everybody can click on run and see to this. Are you getting the waveform or not? Please let me know. Click on run. Just click on run. Have you all done? Please post it in the group. Tap the run button in EDA playground. Thank you. Someone has responded positively. Thank you very much. Are you able to observe the waveform like this? Others also, please join. Thank you. Thank you very much. So 2 participants have tried. I do not know how many of you have tried it. So I have made some reminder also in the group earlier. Thank you very much. Someone has posted now. Sir, this is not end of System Verilog. It is only beginning of System Verilog. Please understand this. We are going to have some more complex things. Yeah, thank you very much. Darun, someone has posted. Very good, very nice. He has posted like the log details of the program, right? The outputs. Log means it is the textual way of observing the things, right? The simulation details. Even if you click on here, click on log. By default, it is in log only. So what I do, I just pull the screen up so that the log screen will be visible to you. Sir, Darun sir, are you able to see the same thing here on the screen? The same thing, right? Please unmute us to talk in Google Meet. Google Meet. Yeah, definitely, sir. Definitely. I'll go to that, sir. Please. I'll go to that. If someone wants to unmute, please raise your hands. Someone is asking, Kalayarasi, sorry. I have admitted now. Sorry for the delay. Someone, are you raising your hands? So that it is easy for me to identify and unmute. Let me check with the keyword or shortcut for unmuting all. Unmute all. Background and effects. Code. Troubleshoot. Okay, I go to settings. Microphone, push to talk, okay. Audio. Someone wants to join. I'm sorry, just a minute. Let me allow you to join. Admitted you. Someone wants to join. Okay, please join. Okay, I just unmute someone who is near me. Sorry, I'm not able to unmute you. Organizers, please unmute the participants because hardly 16 members are there. Whoever the organizer there in the meeting, please unmute them. I want to interact with them, please.
See, participants are requested.
Pardon, sir?
Yes, sir, I'm moving. Wait, sir.
Okay, thank you very much, sir. Someone has asked me this question. Please tell the procedure how to get the waveform. Very interesting. The thing is, sir, in the EDA wave is there, right? In the EDA playground, in the left hand side, you have a scroll bar, sir. In the scroll bar, what you do, the very first thing is your test bench and design the programming language may be appearing like Verilog or System Verilog, sir. Please choose that one, sir. Verilog or System Verilog. The rest of the things are not mandatory, sir. Come for tools and simulators. Under this, you can go for several tools. You preferably go for iCaras Verilog, one of the open source simulator and popular tool. So you can select this iCaras Verilog 12.0, whichever version is there, you please select this one, sir. And most importantly, run options is there. Under that, you click on open EP wave after run, sir. Please click on this. If it is not tapped, you will not get the waveform. So once you click tap, then again you run, sir. Please run again. Please run again. You click on this open EP wave after run. This should be enabled, sir. Okay, the choice has given for all of you to unmute yourself. So please unmute and speak freely. Unmute yourself and speak freely. Sir, is it okay for you? Someone has posted a question to me. Yeah, exactly, sir. Thank you. Thank you very much. Someone has posted this, right? You follow this one. Open EP wave after run. You put a tick mark on that. Once again, you please run. Definitely, you will get the waveform. Please run and let me know if you have got the results. Please convey the response.
Excuse me, sir.
Yes, please.
I selected System Verilog. But in the next option, what you said, sir? UVM, OVM.
1 minute, sir. 1 minute, sir. I'll come back here. Is this the screen, sir? System Verilog or Verilog, right? Languages we supposed to select, sir. Once we have done, okay, you go for tools and simulators, sir. Tools and simulators. This blue color one.
Okay.
Under this, you select one of the simulators, sir. I have chosen iCaras Verilog. You can go for Altec Rivera also. Rivera also one of the popular simulation tools, sir. Altec Rivera.
Okay, sir.
Once you have done this, please come for run option. Okay, run option. Compile option may be there. Else you click on. By default, it may come once you select iCaras Verilog. In the run option, click open EP wave, sir.
Okay, sir.
EPV nothing but EDA playground, sir. This is the first tool. EDA playground is the first tool to introduce this waveform viewer. EDA playground waveform viewer. So built-in waveform viewer is there. Once you select this and click run, sir. Please click run.
If I run, it says that validation error.
Pardon, sir. What do you get?
Validation error.
Validation error. Validation error means have you opened the same file, sir? Is your design available there? The same program,
Yes,
module.
Your file
everything
already
there.
opened.
Fine, sir. Fine, sir. Very nice, sir. You better do one thing, sir. You copy the file, sir. Please, once you copy the file, click on copy, sir. Click on copy. Because when multiple members are trying to access the same file, right?
You are
It may.
showing right side or left side, sir?
Have you click on copy, sir?
Which one I need to copy?
No. You click on copy, sir. No need to do anything, sir. Just you are going to copy the whole file, sir. Whole file.
Okay, I copied. Sir.
Copy means you get a name under that, sir. Bottom, you may get some name, sir. Do you get the name, sir? Once if you click copy, if you click on copy, you supposed to get here the name and get something like 1, 2. Is it
Yes,
so,
sir.
sir?
Yes, sir. Yes, sir.
And if you want to modify the name, then click same, sir. Slightly you modify the name, then click save, sir. So then it will become yours. So it will be personalized for you. It will be added into your own playground, sir. Thank you very much. Thank you very much. So someone has got the response and posted in the group. Thank you very much.
After saving,
After save, now click run, sir. Now click run, sir.
again only it is same.
Wait for a moment, sir. Wait for a moment. Please.
Or else I will do it from the beginning, sir.
Not a matter, sir. Please try this one, okay? Make some changes in the program, sir. Instead of A and B, I request all the participants to try to edit this. And instead of and, you go for cap symbol. It is XR gate. Now it becomes XR gate, okay? Let the name remains same. If you want to change the name in the design block means you should change in the test bench also. Somebody can try with this also. A XR B, right? Save the file once again. Now you can run it. Are you getting the waveform now? When the inputs are different, output is high. When the inputs are same, output is low. XR gate. Is everything okay and fine? Dear participants, 1 or 2 members, please try this. Thank
Yes,
you
sir.
very
I
much.
got it.
Thank you very
Thank you,
much.
sir.
So I will show the symbols for some of the operators. You please try this. For OR gate, in your keyboard, above the enter key, you could see a vertical straight line, right? A vertical straight line. For OR gate, I have posted in the group. You please see. For OR gate, you can change the symbol of AND into OR. Then you can run it. In the same way, for XR also you can try. XR, the symbol is this one. I have posted there, right? XR, this one. For AND gate, this is the symbol. AND gate, this is the symbol. And you can try with the NAND also. NAND means a tilde symbol is there. Tilde symbol followed by AND. Tilde symbol followed by AND. So you can type this keyword for NAND. Everybody can try in this. Please look into this. I have the chat here also, chat window. I'll try typing chat in the chat window also. Chat window, right? Chat window. For AND gate, you can go for the symbol like this. For OR gate, you can go for the symbol like this. Right, the vertical straight line, same thing. Right, please try this one. Some of you can run this program and give me your opinion on this. Are you able to follow this? So that I can move on to the next level of verification. We have done with the combinational circuit. The next one will be sequential. Please tell the procedure how to get the waveform. I'm really sorry. Let me go with the procedure once again. So someone says that asking for procedure. So let me close the waveforms here. And as a first thing, please go on here, your playgrounds. I suggest everybody to please click on this playground and go to your playground. I hope everybody has logged in, right? You might have logged in with your own username and password. Am I right? If so, your YouTube screen, Not clear, sir. Okay, let it be not clear. You please join with Google Meet also. Google Meet also you can join. Nothing wrong with that. Please join in Google Meet also. Have they posted the Google Meet in the group? Link for Google Meet? Prabhu, sir? Sir, shall I share the link to them in the group? Let me share the link to them so that some people feel that the screen is not clear. I have posted in the group. So some of you says visible, some of you says got the waveform. Thank you very much for your responses. Please be interactive. That's all. It's after all, we are all in the teaching community. We normally encourage our students to speak, right? The same we supposed to exhibit from our end also. And more join this call. Multiple people wants to join. I'm really sorry. Let me join. Make you join, everybody. Joined. Right. Has everybody joined? Many members are requesting joined. Okay. Okay, thank you one and all for joining the meeting. I believe that you might have found some difficulty with YouTube, right? So let it be. And here all your you will be able to unmute the mic whenever necessary. Please unmute yourself and speak. Okay? You can unmute yourself and speak. Let me move on to the procedure because others are waiting, right? I should not waste their time. Let me move on to here. Someone is asking for the procedure, right? So what you supposed to do once you go for your playgrounds, you please see to that are you getting a file with the name AndGate 12 wars 1? Please see to that. Are you getting a file with this name in your playground? This is the first thing to be verified. If not, what you supposed to do? You click on copy. You get the file name under this. You please click save. Then only it will come into your playground. Okay, the file will become yours. Whenever necessary, you can edit and change it, right? So make it yours. Someone has asked, right? Is your doubt clarified? Some sir or madam asked a question. Okay, thanks. I believe he or she has got the idea behind this, right? So you supposed to click on open EP wave after run. That's all. On the left hand side, everybody please click onto this open EP wave after run. EP is nothing but EDA playground wave waveform viewer. So now I move on to run the program. I click on run. I have the program for AND here. So I get the response in this way. How many of you have tried with the XR gate or NAND gate? Can somebody please respond, unmute and speak? Tried with the NAND gate or XR gate? You can put it in the chat box also. Other logic gates. Other logic gates. Anybody posted message in the group? Other logic gates?
Excuse me, sir.
Susi Kala, I believe, has responded with. Yes?
I
Durai
have
sir. Yes, sir. Yes, sir. R gate, sir. Thank you very much. Thank you very much. Everybody, I suggest you to make some simple changes and try this once. After all, like a game you play. Let us move on to a little complex program. and I want you to write the program. Sir, Dorevel sir, something you want to speak, sir. Please tell me, sir.
Yes, sir.
Yes, sir.
Sir, is it mandatory to write test bench also?
If you want to observe the waveform, you want to apply some input to a design means test bench is mandatory, sir.
Simply writing code alone is not enough.
Simply writing code is enough, sir. Once upon a time we have done like that only, sir. Once we were using Xilinx ISE, right? Xilinx
Yes, sir.
ISE simulator with the FPGA boards. We might
Yes.
have received some 10-15 years back, sir. I believe 10 years back. We used to receive Xilinx ISE simulator along with the FPGA board. Normally they prefer synthesis only, right?
Yes, sir.
They give less importance for simulation. What they suggest us to do, they go for only design program. They ask us to go for running the simulation. Once you run the simulation, you get nothing in the waveform. There you will right click on the waveform and force some values into the waveform, right? You can click and force the waveform itself. Your inputs may be forced there. When you run, you get the response.
Yes, sir.
That approach is there, sir. I don't claim that it is not at all possible. Definitely it is there, sir. Thanks for asking this question. Actually, it is done long back. Thanks for recapitulating the old thing. Anybody else having other questions? Anybody else? Okay, OR gate, someone has tried. Nobody else? Okay, OR gate, AND gate, good. You can try with XOR gate or XNOR gate. Simply change the symbols. I'll post the symbol for XNOR gate. Someone can try this. It's a matter of minute. You change the symbol, run the program again. XNOR means keep the symbol of XOR followed by tilde, nothing but not. The other way of doing XNOR is first you keep not, I mean the tilde followed by cap. Right? Both are equivalent. Nothing wrong with that. The cap symbol represents XOR. Shall we move on to the next one? I think we have taken enough amount of time, almost half an hour for doing a simple simulation. We have many things to learn in programming also. Let us move on to a simulation aspect of one more program. Then we will move on to program. We will come back again for the last or final module of simulation. Is it okay for everyone? If so, please put a message that we can proceed. As a request, I want people to join YouTube also once or twice as a participant. Make your presence there also, in the YouTube also. Sometimes if they take YouTube as a evidence or procedure of attendance, that will help you. So once you log in with YouTube also, and better to keep it mute. Many members are interested to join now. Okay, shall I proceed now? Okay, 2 members have responded. Keeping this as a sign, a positive sign from everybody, let me move on to the next one. Okay, I'll move on to the next one. It is only for practice, not to take much time from you. Let us go for the next playground. One more thing, sorry. In this program itself, let us look at the log window, right? The log window. Please observe here, everybody, please observe here. Can you able to see this? Your program completed running successfully and it shows the results, right? At 0th time, our A input is 0, B input is 0, output value is 0. At 10 units of time, at 20 units of time, at 30 units of time, look at the things. We have used $monitor, right? The $monitor followed by dump.vcd, right? So the $monitor shows the response in the log window. And this dump.vcd will help you to see the waveform in the EP waveform V1. Is the thing clear? You want to see the result in the form of text, you can look at here, like using $display or $monitor. You can see the results of your program here itself. So that also you have the option to verify your design. Okay. And once you go for complex program and all, things will be preferred to verify in the log only. Because when there are error, some set of errors that can be observed only through log window, which particular line there is an error, and what are the possible ways to rectify it and all it will suggest. Is it a syntax error or some semantic error? Everything will be suggested here. So now and then you have a practice of watching this log window also, right?
Sir,
Fine.
once I click run, directly it goes to waveform window, sir.
You want me to show the waveform viewer? Yes, sir, please.
No. Directly it goes to waveform window, sir.
Okay.
Then how to verify log?
Log means from this is in one tab, sir. Waveform viewer is in one tab, sir. Now click on the previous tab, sir. Your design. That in that we have a space here, sir. We pull the screen up, sir. This one, design and test program. You pull the screen up. Naturally, you click on the log, sir. It will be observed. You can observe, sir. Log and the share options are there. Click on log. You can able to view that, sir. Are you able to do it, sir?
Window,
Yes, sir.
the same window, it goes to waveform.
Yes, sir. Next window, sir. Next window.
Not
Tab,
next
tab.
window.
New tab. You have to go, sir.
The same window only it is coming like that.
Okay. Then there could be a setup in your mobile phone or computer, sir. It opens
Okay.
everything in the same tab.
How to get it in separate window?
That is there in the settings, sir. In your computer settings, it is possible, sir. Open new tab in a new window or new tab and all. Okay, that could be the issue with your system, sir. It's not a major one. Let me suggest you one more thing, sir. Once you click the waveform viewer, sir, close this waveform viewer. Naturally, you will come back to your design. Close that one, sir.
I close it.
Okay, now can you able to see your design and test bench program, sir? Right hand
Yes, sir.
side design program. And the bottom, can you see log option, sir? At the
Now I
bottom,
can see.
click on logs, sir. You will be able to view that, sir.
Yes, sir. I can see.
Is that okay, sir?
Yes, sir.
Thank you very much, sir. Thanks for interacting with us. Now, it's time for us to go for our next verification. Now, we are not going to take much time here. It's only for a simple practice again with a new kind of program, okay? Slightly complex program we are going to take up. Now, this time what you do, you click on the second link, sir. Everybody, please click on the second link. Already I have posted the message, right? Please click on the second link. Because some of the participants joined later, I would like to post the same message in the group once again. Everybody, please click on the second link, not the first one. Now we are going to verify 3-bit asynchronous counter. Okay, which is going to have the values from 0 to 7. Also called mod 8 counter. Have you all opened it, sir? Have you all opened it?
Yes, sir.
Fine, thank you very much, sir. So, as usual, we have two modules, one on the right hand side, one on the left hand side. The right hand side is your design program.
Sir,
Yes, madam, please.
sir, under tool and simulator, we have to choose open EP wave and after run, sir.
Not after run, madam, before run. Open EP wave, we should click before run, madam. So you click on open EP wave first, then go for run, madam. Please try this one.
Okay, sir.
Because by default it will open. Once the program having no error, then it will automatically open the waveform for you. Okay?
Okay, sir. Under UVM/OVM, whether we have to choose anything there, sir, or none, we have to choose UVM.
Where, madam?
The
below one example, sir. May I know where you want to?
Left
Other
hand side.
libraries, sir. Other libraries, sir.
Other libraries, yes.
No need, madam. You need not select anything. By default, it comes, right? We are not going for any complex design. After all, we go with a logic gate, right? We need not select any library.
To choose only open EP wave before run.
One more thing, madam. Simulator also. Simulator, have you selected? Tools and simulators, iCaras Verilog. or Aldec Rivera, any one of the tools you please select.
Okay, sir. Okay.
Please ensure these two things, that is enough. One is the simulator. Programming language by default, it comes with the system Verilog or Verilog. Okay. Simulator
Okay.
we need to select, followed by open EPWave. We have to put tick mark. Then you click run. Are you able to see the response? Others, in the meanwhile, I request you to run this program, please. Everybody, please run this program. Others, please run this program. It's a counter program. Let us see, does it count or not? Is everybody getting the waveform? Somebody please post messages in the group if at all you find some difficulties. The second one, 3-bit asynchronous counter link I have posted in the group.
Sir, we are getting output,
Okay.
but how to check clock is counted or not?
Let us come to that point, sir. We have to verify through program, right? It's an up counter, sir. It's an up counter, right? Synchronous up counter.
Waveform window, it shows only 3 or 4 waveforms, not waveform, clock.
Only 3 clocks, sir. Are you looking at my screen, sir? Are you able to see my screen?
Yes, sir. No, I'm not getting like this.
Okay, click on plus then. If you click on plus, are you able to view? No, I'm not getting it. Yes. You click on plus, you will be able to elaborated waveform. This is one thing. The second thing is radix, sir. Radix, normally I have kept decimal. You can go for binary also. If you keep binary, you can view the waveform in binary also. Right? You have the options to change, sir.
No, sir, I'm not getting like this.
What do you get, sir? You're not getting any waveform at all? If so, is it so?
I'm getting
Please
waveform.
post the screenshot in the group, sir. In the group, please. In the WhatsApp group, you please post it. The screenshot. Let me check it once.
Sir, I am also getting only one yellow line, sir. That is clock. Count is not coming.
Hey, madam, you please do one thing, madam. Please click on get signal once. Get signal. In the
Okay,
left hand side, can you see get signals? Click on test bench. It shows both. Are you getting it? Click on test bench. Click get signals. You
Yes.
get a waveform screen like this. Click on test bench. You get both the signals, right?
Up and all.
Exactly, sir.
sir. Up and all, sir.
Yes, madam. Exactly, madam. Up and down. Append means already waveform is there. Again, I am adding it. That's called appending. Okay. And if at all you don't want any waveform, please click there. Sir, please click there. You have the option.
No, it came, sir. Count came, sir.
Yes, sir, I am getting. Sir?
Has it come? Okay, madam. Thank you. One more thing, madam. If at all you find some signal you don't want,
Professor?
Yes, sir.
Sir, sir is disconnected. Check it.
Yes, sir.
Any problem from the side? Yeah, connected, sir.
Yes, sir.
Regular. I have internet connection in a nice way here, 180 kbps. Maybe some fluctuations could be there. Is everything okay?
Yes, sir. Yes, sir. It's connected, sir. You can share your
Yeah.
presentation, sir.
Yeah, screen is going out. I'm sorry. Maybe due to poor signal. Are you all getting the waveform?
Yes, sir.
For any questions or doubts, please post it in the group. It is our time to discuss. Someone has said that the waveform is
Yes,
not
sir, we are getting, sir.
Someone, Darun sir, is the problem rectified? I got like that. Someone posted Darun, maybe Darun sir. Okay, I also got. Thank you very much. So happy. I hope this is only a simple kind of. Now I got it. Thank you very much, sir. Thank you. Thanks for your response. Now I'll move on to the program because somebody has asked me this question. Right? Explaining this particular program may take much time. Let me simply outline the things, how it happens. Right? Actually, this particular program is having hierarchical approach. Right? A flip-flop. First, we start with a T flip-flop, the low-level module. Starts with the keyword module, terminates with the end module. The T
Sir, sorry, sir, the screen is not, sir.
Screen?
So screen is not visible.
I'm sorry. Maybe connectivity issue. Yeah, exactly. Let me share the screen again. I'm sorry. Maybe that could be the issue, right? Yeah, thank you very much. Is it okay now once you please see the cell?
Yes, sir. It is visible.
Thanks for your response. I'll move on to this. Okay. Please look into here, sir. Module, keyword module and end module in the program. Actually, there are two units here. One is your T flip-flop, which is your low-level block. At reset, your Q becomes 0, right? If toggle input we apply, right, the Q becomes Q bar. Whatever the value earlier it had, it is complementing. If T in equal to 0, then Q remains same. That's all. This is your T flip-flop, right? Most of you may be familiar with this. Okay? And combining these T flip-flops thrice. So T flip-flop, again T flip-flop. 3 instances, the instance names are T1, T2 and T3. I hope you might have noticed these things in the waveform viewer, right? Dot T1, dot T2, dot T3. Do you remember this? These signals we can observe like that, appending. So these are the instantiation of modules. Similarly, the counter instantiates the T flip-flop. Where is that? How do we instantiate T flip-flop? T flip-flop thrice here with the T1, T2, T3. I have made a counter. I have to call this counter with the name M1, right? The counter is called into test bench program with the name, instance name of M1. That is another reason in the waveform we have got M1 as another variable name. Right, sir? Any questions up to here? Please. Somebody may be interested to know the structural aspects of this T flip-flop, how it is being combined and all. If so, actually I will share that file also. I have made it as a sample program in System Verilog. Right? So full adder, T flip-flop. This is the one, sir. Is it visible for everyone?
Yes, sir. Yes, sir.
Yes, sir.
3 flip-flops are combined. The first flip-flop receives external clock, whereas the second one receives Q bar as clock input. Please look at here. The third one also receives Q bar of the previous stage flip-flop as clock input. And toggle flip-flop, all 3 flip-flops receives a T input as 1. So every time it is going to toggle. Okay, na, sir? So I'll come back to here. So we call the counter program into test bench and we are applying the input in this way. Like clock initially we make 0 and toggling the clock. This is a way of generating the clock signal, right? Clock equal to 0 and after 1 unit of time it is going to toggle, not of clock, right? So this is called your clock generation unit in this program. So for every clock the system is going to change its value, right? And the change is being copied into this file called $dump. yes, $dump file with a dump file name and dump all the variables. You can go for selected variables, or if I do not mention any specific variable, all variables will be copied into this. All variable means your counter unit, your timer unit, right? All the variables related to that will be combined, put into dump.vcd, and this is your test bench file. The moment we run this file, we get the waveform like this. And you can view the waveform, please see sir here. Binary, decimal, signed decimal, ASCII. There is an option for analog also. Probably we may not be going with any of the examples here. And the hex option is there, right? Because we have hardly 7 as the maximum value. Once you go more than 9, you will be getting A, B, C, D and all, right? So it's not going to make any difference. Either hex or decimal, it's not going to make any difference. Fine. Any questions here, sir? Shall I proceed? Somebody please respond.
Sir, yes, sir. You can proceed, sir.
Okay, let us move on to the programming aspect. Some fundamentals of programming. Actually, I plan to complete it by 7:30. Let me move on to the programming also later, because we have left somewhere for hands-on session here, I think. Yeah, this is where we have left. Is it correct, sir? Now we are moving for the programming aspect. So let me quickly go through the programming fundamentals of System Verilog. Normally, it starts with the keyword module and the name of the module, followed by list of ports. We define output port, followed by input port. If any intermediate signals you want to define, you can define with the keyword wire, range. And in System Verilog, you can define variables with the integer, float. Float means here it is real, right? Integer, real, string, all the data types you can mention here, followed by the functionality. You can describe everything here. Finally, you terminate with end module, right? There are various options available to specify the module in your System Verilog programming. It is much like your System Verilog, sir. Except that you, instead of module, you can start with the keyword class and terminate with the end class. You may start with a interface, a keyword called interface, terminate with interface. These are all new features introduced into System Verilog, whereas only module and end module is there with Verilog. And module instantiation, as I said before, once you call some of your program into another program, right? You have to call the module name, followed by instance name, and the port connection we need to specify. In the same order, or you may go for out of order by neglecting 1 or 2 ports also possible, right? So this is module instantiation. Connecting ports by order is one possible way. Connecting the ports by name also another way. Normally, connecting ports by name is preferable. So it is the advice given to you, connect by name. Okay. These are all the fundamentals of Verilog programming. Please go through it, sir. Actually, I may not spend much time on this. Let us take some examples for combinational logic and sequential logic. One simple example for multiplexer is there. Once the session is over, I want the participants to copy this program into the EDA playground, and you can write the test bench program. Simply edit the program, sir. What we have done with the AND gate or counter, you can edit it by changing some new values of input and run your program. Definitely, you will get the response. If at all any queries, the group is available for some days, right? You may post the group. I am here to respond for you. And this is your structural design, right? Multiplexer, how do we describe it? Like calling with the keyword NOT gate, AND gate, OR gate. Are you able to see this, sir? Structural design.
Yes, sir.
So here, these are the set of keywords available for the output variable comes first in a logic gate. This is the syntax, we cannot change it. Always output first, followed by inputs. We all know that, right? Logic gate always having single output. It can have 1 or more inputs, right? So in this way, we have to go with the structural design. And this one we have practiced, I believe, continuous assignment, right? The same multiplexer with the continuous assign. I'll just go with this one. Continuous assign, we have used this one, right? For variable C. This is the variable C. How it is being mentioned? So I take select as input. select as input and its complemented value. So not of select is one of the inputs, and the other input is A, right? For this particular AND gate, A is one of the inputs, not of select is another input, and it produces a result called C. The C and D together apply to F. So F is my output, C and D are applied as input for this. This is our OR operator. Is that okay for everyone?
Yes, sir.
Continuous. And this is one special kind of operator. So checking the value of select. If select value is true, I mean logic 1, B will be coming to the output. If select value is false, 0 means A will be coming to the output. This is called, they call it as a ternary operator, right? So we have input conditions followed by 2 possible outputs, and finally an output variable. This is, you can try this also in programming. One of the beauty of system Verilog is that you can specify the procedural block with the name always_comb, always_comb. In Verilog, we have only 2 procedural blocks. One is initial block. With the keyword initial, we have declared some values, right? Which executes only once. Always means which executes multiple times. You can go for conditional execution also. This always block having multiple options. Always combinational, always latch, always flip-flop. Now in system Verilog, these things have been introduced. This is always combinational block. Right? This is only a syntax. Let us see the example in the next slide. How do they declare? This is called a behavioral approach, sir. This approach is called behavioral approach. Something like in C program, how do we specify? If select input is 0, A will be your output. Else, B will be your output. Is that clear, sir? Instead of describing in terms of logic gates or writing with assign keyword and operators, you can go for C-like programming. If, else, for, while, case statements and all we can use to describe the behavior of a combinational circuit. Okay, sir. Any questions in this? So same thing, there are multiple assigned values, vectors can be assigned. I'll skip on these things, arithmetic operators and all we have seen. I'll move on to 1 or 2 examples in sequential logic also. So earlier we have seen combinational circuit where the results are not retained. That means the moment you apply the input, it produces the result. For some input combinations, the output may go to high impedance state, right? But whereas in case of sequential circuit, the output will retain the previous values and show you the results, right? Because it involves some memory elements like flip-flop, latches and all it involves, we use sequential circuits. That sequential circuits, we may take up examples of the registers, counters, finite state machines and all. And this has one new feature, sir, called always_flip-flop. Also, we have a construct called always_latch. Latch means level triggered, flip-flop means edge triggered, that everybody know. Let me show you the example for this. Edge triggered events. What is meant by edge triggering? Right? In the clock signal, everybody know, right? This is called a level of the clock. High level, low level. This is high level. This is low level. Again high level. Edge means this transition, 0 to 1 transition time, 1 to 0 transition time. The 0 to 1 transition is called a pass edge, positive edge. 1 to 0 transition is called a negative edge. So this pass edge, neg edge, and all we can take up as condition, and we can specify the behavior, when the Q should change, when the Q should go to 0 or 1, that can be specified within this block. We use a keyword called always flip-flop. This is available only in system Verilog. It is not available in a normal Verilog program. Okay, a sample system Verilog program is given here. Please look at this. Okay, module name I have given as flip-flop. Please understand that flip-flop is not a keyword. I have used flip-flop as a name or identifier. D, one of the ports, Q, another port, clock as the third port. Where D and the clock are input, Q is my output. Now you can see a keyword called logic here. What is logic? Any idea? Somebody here? Send me all PPTs. Definitely, sir. It will be handed over to the organizers. Definitely, we are going to share the PPTs. And also, in some of the PPTs, I have mentioned the link also, reference link, where you can go and get study more details. More than PPT, you can definitely get the information out of it. So that's our flip-flop, sir. Only. So without any reset, this is approach number 1, sir. Approach number 1, we are not using any reset here. Without reset, we are doing it. So during the positive edge of clock, whatever the D input we apply, it will be copied into Q. That's all. This is approach number 1. Let us take approach number 2. Approach number 2 also we are specifying only flip-flops. But this time, we are taking the reset input also. That reset input, I am taking negative edge of the reset. So whenever the reset input goes from high to low, during that time, it will enter into the block. Okay. So it checks for 0. So when transition happens and going into 0 means, then your Q will become 0 because your reset is activated. Else, if reset is activated, not activated means, negate is not activated means, the other way of entering into the module is positive edge of the clock. Because positive edge of the clock is true, you are going to make the value of D into Q. That's all. So with reset. Is that clear, sir? This is approach number 2. Approach number 3, we are defining the same flip-flop now with the synchronous reset. What is meant by synchronous reset? We have one unique control signal called clock. Only clock is successful, then we will check the reset. Earlier we had 2 options, either positive edge of the clock or negative edge of the reset. So reset is independent, clock is independent, right? So reset and clock need not be interrelated, right? We need not check the value of reset at pass edge of clock or negative edge of clock. We can check at any instant of time. Whereas here, this is synchronous reset means we have only one control signal to enter into the block. That means only during the positive edge of the clock you enter into the module. By that time we check is reset signal is equal to 0. If it is 0 means we go for Q output to become 0. Else D will be copied into Q. I hope it is more than sufficient to speak about flip-flop. Multi-bit flip-flop means nothing but register, right? How do we say it is multiple bits? Because we declare 15 down to 0. 15 down to 0 means it's a 16-bit variable called Q. The same thing, Q equal to 0, 16-bit 0. Q equal to D. What is the value of D? It's a 16-bit value, right? It's a register. Basically, it's a 16-bit register. At the pass edge of clock, we are copying the value of D into Q. So 16-bit value we are copying. Nothing but multi-bit flip. Right, sir? So there are keywords called parameters in a Verilog programming. The purpose of this keyword called parameter is to modify at the time of simulation. Suppose you develop a memory with a size of 8 bits. Now you want to change it into 16 bits. At the time of simulation, you can change it. So in the design, I set a default value to be 16, right? When I instantiate this particular flip-flop, my flip-flop into another unit, I don't specify anything means, naturally it takes that the parameter width as 16. Width is 16 means each memory location stores a value of 16 bits. Those are, I want to go for a value of 12 bits to be stored into the memory means, pass on this argument with called hash in bracket 12. So this changes the parameter value to 12. So default value is 16. If you want to change to 12 means this is possible here. Okay, sir? Is that okay for everyone? We have one more hands-on session. I would like to take up another 5 minutes or 10 minutes to describe this hands-on session. If you have any questions about the part what I have discussed so far, you can ask any questions.
Sir, logic is data type, na sir?
Pardon, madam?
Logic.
Yeah, very good, madam. Logic is also data type. It is 4-state value, madam. It has 4 state
Okay.
values. 4 states. That means, like our, we normally say wire, no? Wire.
Yes, sir. Wire and register.
Yes. In the same way, system Verilog, they have introduced logic, madam. Normally,
Okay.
wire we use for continuous assignment only. as an output variable, we can use only wire for continuous assignment. For procedural blocks, we have to use only registers, madam. I hope you might have practiced well. In case of logic, you can use it for continuous assignment as well as procedural block as an output variable. Very interesting question you have raised, madam. Thanks for this question. Basically, it is a substitute for combination of wire and ridge. Okay, so this queue may be used inside the procedural block called always. The same queue may be used in continuous assignment, like assign keyword we use now. There also we can use the same variable. But if I do with Verilog without using logic, it will show you the semantic error, right? The variable wire and ridge may not be compatible there. Instead of using wire and ridge, use logic, right?
Okay, sir. Thank you, sir.
Thank you very much.
Thank you,
Anybody
sir.
else?
Meticulous.
Pardon?
Thank you, sir.
Thank you very much, madam. Thank you.
Well done, sir.
Any other questions about these flip-flops or edge triggering event combinational blocks? Actually, there are many aspects which may not be covered within a span of 2 hours. Actually, I learned this as a course for a span of 3 months. System Verilog as a course for 3 months, but still in the practicing level only. So it really requires lots of time. Actually, we have taken a right platform now. We have learned some basics of programming. We have taken a sample tool also, an EDA playground tool. These two are sufficient for you with this basic idea on the programming language. Rest you can learn through internet study and practice by yourself. Rectify the problem, take some help from guidance, some experts who are in this field, right? The resource materials or study materials are available. You can learn by yourself. Okay. Shall I move on? The last one I would like to show you. Is that the third hands-on session. Okay, it's already time. Okay, so let me complete the session for today. I suggest you to take up this particular thing in your free time, right? The third link is there, right? Full adder system Verilog. Full adder system Verilog, you can take it as a homework problem or a practice problem at your home. There is a design unit here. There are n number of modules within the test bench. I'll pull down here. Okay, like your test monitor, scoreboard, everything is there. If time permits, I'll share the link also. You watch and practice this. Thank you very much for actively joining this session and interacting with me. It's already time up. We have to complete the session in order to go for valedictory. Thank you very much. Thank you, Prabhu sir. I close the session here. I close my discussion here.
Yes, sir. Thank you very much, sir. Thank you very much for your wonderful session and fruitful hands-on session. Thank you very much, sir.
Now I call upon Dr. Kamachi Madam to say vote of thanks. Kamachi Madam.
Yes, ma'am.
Please, ma'am, the floor is yours for vote of thanks.
Yeah, wait, ma'am, wait for a second. Let all the resource person join, ma'am. Wait. Anybody is having queries, you can raise the queries.
Excuse me, sir.
Many members are asking for the PPTs. Definitely, it will be shared by the organizers.
Sir, what what is the difference between Verilog and System Verilog?
Sir, Verilog, it is very similar to the difference between C and C++ programming, sir. In C programming, we don't have object-oriented programming concepts, sir. The object-oriented programming concepts naturally help us to go for class kind of programming, sir. So class means once you define a module as a class means the same may be called into another program with some modifications also. Derived class, might have studied polymorphism, inheritance and all. That feature is available, sir. Second thing, there are new kind of data types are introduced. Just before we have seen always underscore flip-flop, always underscore latch, always underscore comp. These are the new kind of procedural blocks introduced into System Verilog, whereas earlier we had only initial and always block. In addition to that, we have got some more blocks that helps us to do the programming in a convenient way. Okay, sir? So new kind of data types, new procedural blocks, and object-oriented programming concepts like classes, inheritance, polymorphism, objects, and there are many aspects we can say, sir, in System Verilog. That I have made it in the initial presentation itself, sir. I believe you might have noticed it, right? If you have any specific question, please post it, sir, in a particular aspect. Yes, sir. Very well, sir.
Yes, sir.
Please tell me, sir.
Sir, I need some reference link to learn this.
The first and the foremost link, I'll post it in the group, sir. Chip Verify, sir. Please type Chip Verify. I post it in the comment box also. Everybody can make use of this Chip Verify. You type in Google for System Verilog, Chip Verify for System Verilog. Definitely you get a complete information in the simplest possible way. A beautiful link to start with. Okay, na, sir? And take the help from EDA Playground also. Okay, I think it's time for valedictory. Many resource persons also waiting. We have WhatsApp group. At any time you can share your doubts or thoughts. Madam?
Yes, sir. May I wait for a few more minutes, sir? Other resource person has to join.
Okay, madam. Meanwhile, if you find the time means we can go for doubts clarification, or you may ask the students feedback about the sessions, various sessions. Someone is asking for link. I'll post it in the group, sir. Just I'll post it in the group. Chip Verify link itself.
Sir, one doubt, sir.
I just stop presenting here now because others have to go with. Right? Yes, please, madam. Please ask your questions, madam.
Sir, here the simulator is there, na, sir?
Yes, madam.
Tools and simulators. What all time we have to select this one, Verilog 12.0?
You need not, madam. Actually, we have given suggestions like Aldec Rivera also, right? Aldec Rivera is there. Icarus Verilog is there. Actually, Icarus Verilog is one of my favorite tool, madam. That's all. You can choose your own. Aldec Rivera is more popular. Okay.
Okay, sir.
The first option you can see Aldec Rivera Pro. That is by default it comes. You can go for Icarus Verilog also.
And down also, sir, compile options also, it will be, it come regularly or we have to change that, it will be coming wall like Z2012 like that, na, sir?
We need not, madam. Normally we go for open EV wave. Only two options we select, madam. Tools and simulator one, madam. The runtime during that open EP wave after that. The two options only we select, madam.
Okay, sir. Thank you, sir.
Definitely, madam. We can practice, and there are videos for more detailed videos about EDA Playground also. You can observe it. You can explore the tool. Actually, I have shown only few, right? How to view the waveform, what are the radix, and how to delete waves or some signals, how to append some signals, and all I have shown, right? So like
Yes,
that, many options are there, madam. Definitely, you can explore the tool. It is an online and free tool. So you do whatever changes you want, you can run it, madam.
thank you, sir.
Thank you, madam. Thanks for asking questions. Somebody else? Madam, organizer, madam, sorry for the trouble. If you have reached the time limits, please remind me so that it is easy for me to start. Anybody else? Somebody wants to speak. Selva Kumarasamy, sir.
Yes, sir. Yes, sir.
Anything, sir? Please
I
continue.
think nice way, sir. Going in a nice way.
Thank you. Thank you very much.
Kamachi, madam.
Yes, sir. Two more person has to join, sir. Just 5 minutes, sir.
Okay, then we can ask them to for a video session.
Meanwhile,
Those who are
you can go
available.
for. I believe. Meanwhile, you can go for some feedback form or any photo sessions.
Yes, yes,
I
we
mean,
have uploaded, sir. No problem. We have uploaded. WhatsApp, we have
Okay,
given
sir.
feedback sessions. No problem.
Okay, sir. Some quiz kind of thing is there that also helps.
Yes, that's 8 to 9, sir.
Okay, sir.
How much, madam?
Yes, sir.
Madam, ask them to open the video.
Yeah.
Those who are available, we'll finish it with them. We'll take running out of time.
Yes, sir. Everybody has joined, sir.
Yes, now you can switch on the camera. Please, all are requested to switch on your camera, sir.
So Vijay Kumar, sir, Jay Shankar, sir. Can you turn on your cameras?
Yeah, already on.
Yes, sir.
Yes. I'm here.
Yes, sir.
Yes.
Organizing members, please turn on your cameras. Good evening to one. Good evening to one and all present here. It is my privilege and honor to deliver the vote of thanks on the concluding day of our enriching online faculty development program on AI-driven innovations in VLSI design and applications. Over the past week, we have had the opportunity to immerse ourselves in a diverse spectrum of topics, ranging in all various fields of VLSI. The intellectual insights and forward looking perspective shared throughout the sessions
Your
have been
camera is
truly
not on,
insightful.
madam.
Yes, sir.
Your camera is not on.
Yes, sir. I extend my heartfelt gratitude to all our distinguished resource persons whose expertise and generosity of knowledge have made this FDP an exceptional learning experience. Dr. A. Brinda Teres, ma'am, Professor, School of Electronics Engineering, VIT, Chennai. A heartfelt thank to you, Dr. Brinda Teres, ma'am, for a brilliant and forward-looking talk on AI integrated VLSI for smart healthcare. Her session illuminated the future of intelligent systems in biomedical applications and emphasized the critical role of VLSI in advancing healthcare technologies. Her expertise and case study driven approach offered our participants a unique perspective that bridges electronics and human well being. We thank you, ma'am. Dr. Sir,
Yes, yes, you can go
yeah,
through.
you can share, sir, full presentation, sir.
Yes, yes, shared, madam.
But it is in the second slide, sir. Fourth slide. We thank you, ma'am, for this wonderful session.
Thank you for the opportunity, ma'am.
Yes, ma'am. Dr. Shankar N., Professor and HOD of IT Department, M&M Jain Engineering College, Chennai. We sincerely thank Dr. Shankar for his insightful session on the role of AI in signal processing with a perfect blend of his theory and applications. He demystified AI-driven techniques in signal analysis and their implications in real-time systems. His lucid explanations and emphasis on emerging research directions truly broadened our understanding of how signal processing is being redefined in the AI area. We thank you, sir.
Thank you, madam. Thank you very much for inviting.
Yes. Dr. Vijay Kumar P., Professor, School of Electronic Engineering, VIT, Chennai. We are immensely thankful to Dr. Vijay Kumar for his expert session on VLSI implementation of cryptographic algorithms. His talk was rich in technical depth and conveyed the vital importance of secure hardware design. His walkthrough of electro encryption techniques and their hardware realization provided a practical sense into a domain of growing global importance, cybersecurity through VLSI. We thank you, sir.
Thank you, madam.
Dr. Sudhagar, Associate Professor, Department of ECE, Bharat Institute of Higher Education and Research, Chennai. Our sincere appreciation to Dr. G. Sudhakar for his excellent presentation on VLSI in semiconductor devices and AI analysis. His ability to interlink device-level physics with system-level AI analysis was truly commendable. He provided a deep dive into the materials, modeling, and innovations that are shaping the next generation of semiconductor technology. We thank you, sir.
Thank you, madam.
Dr. S. Ravi, Associate Professor, Department of ECE, Goodavalu Engineering College, Andhra Pradesh. We extend our warm thanks to Dr. S. Ravi for his methodological and practical session on the fundamentals of system Verilog programming. His approach in simplifying syntax simulation and verification methodologies made a lasting impact on participants, especially those stepping into HTL-based design. His clarity and approachable teaching style were widely appreciated. Your sessions, we thank you, ma'am. Thank you, sir. Your sessions were not only thought provoking, but have also sparked new ideas for future research and collaborations. We are truly grateful for the time and effort you invested. I also take this opportunity to thank our management, Savita School of Engineering, SIMATS Engineering, the director ma'am for her constant support, and principal sir, and all our faculties and organizing members of this FDP in successful conducting of this FDP. Your vision and commitment to academic excellence have been the backbone of this entire program. And last but not the least, to all the participants, thank you for your enthusiastic engagement and active contributions. Your presence, questions, and discussion have made this FDP truly interactive and dynamic. As we wrap up this FDP, let us carry forward the learnings and continue to collaborate in our shared pursuit of innovation in VLSI and AI. Once again, thank you all. Wishing you, everyone, a success and continued growth. Stay inspired and stay innovative. Thank you all for the informative sessions.
Thank you. Thank you. Thank you, madam, for inviting.
Thank you, madam.
Thank you, sir. Thank you, madam.
Thank you, sir. Thank you.
Thank you, sir, and thank you, madam.
Thank you all.
Thank you very much, madam.
Thank you, sir.
Thank you all.
Thank you, sir. Kamachi, madam. Kamachi, madam.
Yes, sir.
Just inform to the participants that they have to complete today's feedback session as well as the online test before 9
Yes,
p.m.
sir. Okay, sir. Okay, sir.
Just give it in the WhatsApp, and tomorrow we will share the overall feedback and the completed the certificate will provide on before Wednesday. Okay.
Okay.
So just give a information in the WhatsApp as well as here also. That
Yes,
will
sir.
be helpful for them to understand.
Yes, sir.
So they have to wait for 2 to 3 days. Once if we complete all the feedback session,
Okay, sir. Participants, your feedback is already shared. I expect everyone to submit your feedback, which is valuable for this FDP. And I'm thankful to all your cooperations. Maybe I'll be expecting this in the further collaborations also. Quiz will be shared in few minutes, and you can take up the quiz session by 8:30. And you can finish off the link within 9:30. It will be closed. So from 8:30 to 9:30, quiz link will be active. I expect everyone to finish the quiz session, and the overall feedback will be sent on all days feedback. So everybody is expected to submit today's feedback quiz as well as overall feedback. I thank you all.
Thank you.
Thank you, ma'am.
thank you all. Thank you all.
Yes, thank you all for that.
Again, thank you, ma'am.